All right, welcome back. We're going to do a second example on related rates. This is kind of a classical type example. You always see this in your first course on this. So the setup is this. You have a ladder. It's 5 meters long. It's leaning against a wall. And unfortunately for the person standing on it, the bottom starts sliding out. So when the bottom is 3 meters from the wall, it starts sliding at a rate of 1 meter per second. And the question is, for the poor person standing on the tip of the ladder, how fast is it falling? All right. Okay, on these, almost always, you want to start with a picture. So the picture you should have, at least at the start, is there's a ladder, and you know it's going to be moving out at sort of 1 meter per second here. And you care about this when it's 3 meters out. And of course, by Pythagoras, right, the hypotenuse squared has to be 3 squared plus sort of the height over there. The height on this side. Let me call it y. If you were to call this side y. And then you can solve from this that y is equal to 4. So in fact this side is 4. Oh, by the way, I did it without even thinking. When they say it's moving at a rate of 1 meter per second, you know, that's velocity, right? And so they ask how fast is this falling? That's a velocity question. So the whole question is, how fast is this tip of the ladder sliding down? Now that we've encoded everything in a picture, let's go ahead and figure out how to solve it. The first step is almost always that you need to have variables. You need to have labels for things, okay? Things that aren't constants. So in this case, the scenario is this. This 5 is always going to be fixed, but the distance the bottom is to the wall, that'll be changing as it's sliding. So we're going to call this the bottom distance x, the top distance y. And it's crucial to remember that x is changing with time and y is changing with time. All our derivatives will be with respect to t, not x. And so you have to remember x is a function and y is a function. Okay? So that's step one. Get some variables, and then rephrase what we know. So we know that x prime, the velocity, the rate at which it's sliding, is 1 when x is equal to 3. Okay, and of course when x is equal to 3, also that's when y is equal to 4. And the question that they want us to answer is, what is y prime? Again, when x is equal to 3 and y is equal to 4. Okay. All right, that's step one. Label things and rephrase the question, usually in terms of derivatives. And step two pretty much always involves taking or finding a relationship. In this case, when you look at it, we've got a right triangle, so it's going to be Pythagoras. Pythagoras tells us that x squared plus y squared is 5. That'll be our relationship. All right, now that we have the relationship, step 3 is almost invariably to take d by dt of both sides of the relationship. All right, so you have to remember x is x of t and y is y of t. So x squared is actually, the derivative of that is a chain rule problem because it's a composition of functions. The outside function is squaring, the inside function is x of t. All right? So when we do the derivative, we take, so just to be clear, if we wrote this very pedantically, it'd be x of t squared plus y of t squared is equal to 5. So you see, it really is a chain rule problem. All right, so we do the derivative of the outside function, plug in the inside, first power, and then take the derivative of the inside, so that's just x prime. For y, we do the same thing. Derivative of the outside is 2 to the first power, plug in the inside, and then multiply by the derivative of the inside, that's y prime. And the right-hand side, the derivative is 0. This is easy to solve. We get, actually we can divide both sides by 2 here. So we get x times x prime plus y times y prime is equal to 0. All right. The final step is usually just to read off your answer and solve the equation. So remember, we were looking for y prime. That was what our question was. But we know all these other numbers. Okay? We know them all, so we're just going to plug them in and find the answer. All right. So x was 3, x prime was 1, y was 4, and y prime we were trying to solve for. So we move the 3 to the other side, divide by 4, you get y prime is equal to 3/4. The units, if you care, will be meters per second. But that means it's going down at a rate of 3/4 meters per second. All right, that is our second related rates example. Ciao.